Hi, welcome to physics lesson. Today we go to chapter 10.1, Newton's law of universal gravitation. The first story of this chapter is what caused the apple to fall down from the tree. Let's analyze together. The apple accelerates from west by Newton's first law. That means it's a change of state in motion. So there will be an acceleration and there is a net force acting on it. The net force actually will be the weight of the object. We cause the weight to be the gravitational force on apple by the earth in this chapter. Okay, gravitational force. According to Newton, every particle in the universe attracts every other particle with gravitational force. Okay, like you see there are two objects, M1, M2. They will attract to each other by the force. This gravitational force between two particles is directly proportional to the product of their masses, that is m1 times m2, and inversely directly proportional to the square of the distance between them. Okay, this is Newton's law of universal gravitation. It is verified by Newton in 300 years ago, mathematically with the equation F equal to gmm over r squared. G, we call this as the universal gravitational constant. We can find this for the formula sheet in the DSC paper, 6.67 times 10 to the power minus 11. Okay, m1 times m2 and then over r squared, inversely proportional to the square of r. Okay, distance between the objects. Now maybe we take a look on the example 1. Example 1, you see there are two particles, x and y, 2 meters apart. Okay, x, y, 2 meters apart. Okay, one is 1.5 kg and the one is 3 kg. So what is the gravitational force acting on x by y? Here, okay. As we know, the gravitational force is attractive, so the force should be to the right hand side, okay, on x by y. The gravitational force can be calculated by the equation gmm over r squared. Okay, so by direct substitution, we know the answer, and the direction should be to the right. Okay, part B. Find the gravitational force acting on y by x. Actually, by using Newton's third law, we know this is an action-reaction pair. Okay, on x by y versus on y by x. Okay, so by Newton's third law, we know is action-reaction pair, so the force will be the same, but the force will act on opposite direction. Okay. What will be the force if the mass of x to be double? So if x is double, the force will be double. Very easy, right? What happens to the force if the distance between two particles is double? That means r double. Okay, and as you know from the equation, F is inversely proportional to the square of distance. So it will be square, so it will be 1/4 of the original one. Okay. Okay, now it sounds easy by using this gravitational force equation. Now maybe we look at example 2. Gravitational force acting on a person. Okay, you see Mary, John. Okay, and then what is the magnitude of gravitational force between them? The gravitational force is actually will be very weak. By the equation, we get this result. Okay, very small value, so they may not attract to each other. In our real world. And part B, Mary is on the surface of the Earth. Find the gravitational force on her by the Earth. Actually, it asks you what is the weight of Mary. Okay, the answer is by substitution. We will find that the force is very large because the mass of the Earth is large. Okay, so the force will be 491 Newton. And part C, the Sun is much massive than the Earth. Okay, now do you think we will have a larger gravitational force acting on Mary? The answer is no. Okay, why? Why not? Why does Mary hardly feel the gravitational force due to the Sun? Okay, so now we know the distance between the Sun and Mary is very large. So by the equation, okay, with very long distance, so the gravitational force will be very small. Okay, due to the Sun. Now, maybe we try chapter 1. Okay, make a good use of the equation to find out the gravitational force. Okay, you may try the answer here. We go to the second part, mass, weight, acceleration due to gravity. You have learned that in long time ago, right? Mass, gravitation, acceleration due to gravity, and also weight. Now you know mass is a measure of inertia, right? And weight is the force. And acceleration due to gravity, we know the value of it should be 10 or 9.81 mx minus 1 if the object is near the Earth. Okay, so now we have weight, and also now we have gravitational force. Gravitational force and weight in this chapter, we know that it will be the same. So mg equal to gm square. So we can find out that m can be deleted in both sides. So we have a new equation. This is very important equation. Okay, g equal to gm over r square. We can find out the value of g, small g, acceleration due to gravity, by using this equation. Acceleration due to gravity on the Earth's surface, we know it will be 9.81. We can use this equation to find out ME or find out RE, radius of the Earth or mass of the Earth, by using this equation. Now you see that we one very important point. The weight of an object is the gravitational force on it by the Earth. And also we have learned that G can be calculated by using this value. Okay, if if the object is on the surface of the Earth, we know G will be equal to 9.81. We call this G naught, 9.81. Okay, we can also find another G value at different position of the Earth. Maybe a higher position. What is the G value? Okay, now maybe we look at one example later. Now before this, try chapter 2. Okay, now after you have done the chapter 2, you may have a check for the answers. Chapter 2. Okay, please tell me if you have any problem. Now, this is a very abstract concept. If I put a massive object here, M, and then we put a point mass, that means very small mass, small m here, we know there will be an attractive force, that is gravitational force. Okay, so scientists would imagine that in this region there will be gravitational field happen in this region. If I put another small charge, small object here, okay, say M1, so it would attract towards the massive object, capital M, okay, and scientists would imagine that there will be a gravitational field existing around the massive object. Okay, we can draw like this. This arrow means gravitational field lines. Okay, field lines, or we say a G field lines here. Okay, if I put another object, okay, let's say M2 here, so you accelerate, and it has a net force acting on it, and the direction will be pointed to the massive object. Okay, so we can see the force has the same direction as the G field lines. Okay, we will define the G field lines point towards the massive object. But we can use the equation to calculate the value of the G field, gravitational field. Okay, that is what we have learned in the beginning part of this chapter. G equal to gmm over r squared. Okay. The gravitational field, the strength of gravitational field is called gravitational field strength. Okay, it's defined as gravitational force per mass. Gravitational force actually means weight mg, okay, over m. So we get gravitational fields will be equal to g. By the equation, you know g is equal to gm over r squared. So that means is we inversely proportional to r squared. So we can plot a graph g against g against r. Okay, so we can find this curve. Now maybe we take a look on the example. Example 4, gravitational field strength. If we have two objects, x, y, okay, what is the gravitational field G? In the DSC, G will not appear because we want you to know gravitational field strength means G, okay? Due to x at the position of y, so we can just apply the equation F equal to gm over r squared. If you forget this equation, maybe you have to think about F equal to gmm over r squared. This is given in the public exam. And also, gravitational force means weight. Okay, mg. So we get a value. We get an equation of small g. Okay, gm over r squared. So we can calculate the answer. So a G field would be 5.34 times 10 to the power minus 11, and towards x, okay, because at position y to x, it should point to x, okay. And what is the gravitational field strength G at position x due to y? So it's asking you about the value of small g. And the G field always pointing to the massive object here, y, due to y. Okay, part C. What is the gravitational force between them? So we can just use the equation mg. So we can find the gravitational force. Because mg is gravitational force and also is equal to the weight. Mg, gravitational force. Okay, we can get the value. We're going to see a very important example, example 5. Actually, you can regard this as a DSC question. Gravitational field strength above the Earth. We know on the surface of the Earth, G is equal to GM over RE square. This G is called G naught, equal to 9.81. Okay, how about if the object is at this position? That is 2 RE from the surface of the Earth. Okay, the answer would be R now become 3 RE. Okay, so what is the magnitude of the G field strength at position of the object? G will be equal to GM over R square. This is the important equation you have to memorize by yourself. Don't forget. And then we can use GMM over RE square. Okay. We know GR is equal to 3RE. Okay. And then we have RE square here, 3RE square. Okay. We should write down like this. This is the technique for the this is the exam technique, because we want to use the fact G naught equal to GM over RE square. So we can get 9.81 times 1 over 9. Okay, the value of G would be 1.09. Okay, ms minus 2, or you can use nkg minus 1. Okay, so this is the value of the gravitational field strength, and the direction will be point towards the center of the Earth. If the question asks you the direction, so you should point to the center of the Earth. Okay, after we know the G field strength, what is the gravitational force acting on the object? It will become very easy. F equal to mg. Okay, so the answer will be 4 times 1.09. Okay, so we get the answer here. This is a very good example. After you have learned this well, you can get full mark in the DSC. Okay, the G field strength and acceleration due to gravity, actually they are the same. Checkpoint 3. Now maybe you have a try for checkpoint 3. This is the answers. Okay, tell me if you have any problem. You see practice 10.1. I hope you can have a try for especially the MC questions. Okay, here's the answer. And also you can have some more calculation for practice. You may download the full solution in the eClass. Okay.